17 is about halogenation of alkanes. All right, so let's just jump right into it. There are a few reasons why halogenation reactions are so important. Firstly, they show just how reactive carbon chains can be. All right, and so for pretty much most of the time, we talk about how straight carbon chains, like an alkane, okay, so alkanes are very unreactive. I mean, they're pretty unreactive, unless if you do a combustion reaction. We don't really know many reactions involving alkanes, right? We know reactions involved with double bonds, alkenes, and that'll be in our reaction video later on. But what about alkanes, okay? So this is kind of an example showing you, hey, alkanes actually can be reactive in this instance, okay? These reactions are so important because they open the door for a multitude of other reactions. So, oh, excuse me. I know, I'm yawning. So this kind of counteracts what I just said. Since alkanes are fairly unreactive, if you want to use them as a building block to make, a massive molecule, or a molecule with like all different functional groups, right? You have to start from somewhere. And if we start with an alkane, usually the first thing we have to do to start actually doing all the different reactions to get to our final products that we want to synthesize is we have to first make our alkane reactive. And a regular alkane is not really reactive. But if we can do a halogenation reaction and put a halogen on an alkane, well, of course halogens on alkanes are reactive. In fact, those are considered leaving groups for SN1, SN2, E1, E2 reactions. So if we can put a halogen on an alkane, we can now open the door to all of the reactions that we covered in the SN1, SN2, E1, E2 sections. And on top of that, we have other reactions that we can do with it as well. And so that's why they're important. They're the first step to letting you do almost anything to get to a molecule of your choosing. All right, so halogen reactions are typically performed on sp3 hybridized carbons. And they feature the addition of a halogen in the place of a hydrogen atom. This is something that's easy to forget, but it is kind of important, right? And that is the fact that we start with an alkane, which has all hydrogens on it, right? And what we're going to do is we're going to take one of those hydrogens off and put a halogen in its place. So if you want to put a halogen somewhere, there first has to exist a hydrogen in that position, okay? So we're replacing a hydrogen with a halogen, okay? So if a hydrogen doesn't exist on a carbon, then we can never put a halogen on that carbon, okay? All right, and these halogenation reactions have a mechanism that involves a radical intermediate or multiple radical intermediates.